we have a number of interesting talks. I'm going to get started by spending a few minutes talking about the Global Supply Chain Management Center and some of the projects we've been involved in with our students. And then we'll move on to two talks, one by Faith Wandry from American Axle. And the second talk is by Carolyn Dygas from Starbucks. And so Carolyn is completing another talk before she walks over and gives us a talk here. So we're going to have all of this done. I know we've recruited many of you to serve as judges for the student case competition, and I hope you'll stay and watch the case competition. So the purpose of this segment is to give you an idea of the kinds of things we do. If you look at what we do and who the staff are, Steve already showed you the staff. The staff consists of Steve Dunlop, who's our managing director, Heidi Alvis, who helps coordinate a lot of our activities, and I serve as the faculty director. But the real work gets done by all our center graduate assistants, and you can see many of them here. I'll have them stand up and be recognized, but that's the group of students who help us as a center deliver on projects. And we're an educational institution first and foremost, so this is an opportunity for them to learn about new projects and play a role. So what I wanted to do was to spend a few minutes talk in depth about a few of the projects to give you the kinds of things that we've been doing. And the best way to get started is to send us an email, send Steve an email to get the ball rolling. So this is our staff. This is the three of us playing a role. We've been doing a lot of interesting, exciting things, working with a number of organizations. I'll mention some in more detail, some I'll just recognize. So, for example, we have projects going on with the Indiana Department of Transportation. One of the rules that the federal government has is of all the federal funding that goes to each state, 1.5% is set aside for research. And it turns out that back in 1930, Purdue is the place that helps the Indiana state spend the 1.5%. That 1.5% is $7.5 million, by the way. So we've been spending $7.5 million since 1930 every year, right? So, but there are very interesting projects, and I'll showcase a couple of things where we've played a role. The second is, and I'm going to recognize Johnny Park, somewhere here. Where's Johnny? Well, I used to watch Johnny Carson. So I only remembered, here's Johnny. I've never made the statement, where's Johnny? But anyway, WIN is a Lilly Foundation funded entity. I'll talk a little bit about what we're doing with WIN. And Johnny Park, who I mentioned, there's Johnny. So Johnny is the CEO of the WIN system. So I'll talk a little bit about what we're doing with them. We have some projects going on with the Department of Energy. I'll talk about one specific project. But I do want to recognize other partners. We have funding from Aurora Advocate Health. I won't tell you the details of the project at this time, but this is something where our students have been involved in the healthcare systems. And so if you look at it, if you look at healthcare, it's a wonderful opportunity to take many of the ideas we have and learn about that segment of the industry. And we have also projects going on with Monosol, which is a division of Curare. And again, that's another project we're going. So let's just talk about some INDOT project. INDOT is, of course, the Indiana Department of Transportation. And I want to first mention one example of a project that they had us do. So if you look at The Economist, and I'll tell you why I say look at The Economist, it turned out that several years ago, when our current president, Mitch Daniels, was the governor of the state, there was a plan to build 2 bridges across the Ohio River. And by the way, it was interesting that the Ohio River is between Indiana and Kentucky. Okay, go figure, okay? Well, it's a river. It meanders onto Ohio. So one of the things that was interesting about that is there were 2 bridges that had to be built, and normally each state would build half the bridge. So they would go to the middle of the river and stop, and then the other state would build. So these guys decided, instead of each of us building half a bridge, why don't you build 1 bridge and we'll build 1 bridge? Okay? It was a revolutionary concept, by the way. Okay? However, now what was interesting is not that they each decided to build a bridge, but each decided to use different approaches to contracting to build the bridge. So Kentucky did not allow any public-private partnerships, but Indiana did. So the Indiana bridge was built using a public-private partnership. which is called a P3, a public-private partnership. And in particular, I should really say, the Ohio River Bridge East End Crossing. Okay. So what does this mean? What this means is that both bridges were built by the same contractor, but the Indiana bridge had basically a deal whereby the construction company could adjust the design because they were responsible for maintaining the bridge for the next 35 years. At the end of the 35 years, they had to hand over the bridge in a condition that it would last for at least 10 more. So that was the plan for the bridge. And part of what they wanted to do was, so the bridge has been built, both bridges are functional. Any of you driving to Kentucky, maybe Roy, you can tell us how the bridge was when you drove over. But any of you driving to Kentucky, chances are you would have gone through one of the bridges. The main thing was to do sort of an analysis as to how one can get the greatest value from such an agreement. So from a supply chain perspective, whenever you think about handing over responsibility for design to a supplier, what you anticipate is that they would choose an appropriate design anticipating the maintenance costs down the line. So for example, they may agree to spend more upfront to decrease further maintenance costs. Okay? They may decide to put LED lighting that costs a lot more so that they can save on all the light bulbs during maintenance. So that's in fact what happened. In fact, the documented data was that the two bridges started off at costing $1.3 billion each, but the Indiana bridge ended up costing $1.05 billion because the construction company decided to absorb some of the costs, et cetera, and get the efficiency associated with it. So what did we do? Part of what we wanted to do was to do an analysis of, we have an agreement with them. There are maintenance costs. There is a toll. How did this overall project work out? What's the net present value, et cetera? And part of the logic with this analysis, which we created an interesting team of students, including some students who were doing our Master of Science in Accounting, and other students who were from the School of Civil Engineering, who are doing forecasts of traffic, et cetera. The main thing we learned is that this is the one main thing. Enabling the provider to manage the design and be responsible for the upkeep. So you made your bed, you lie in it. I mean, you built the bridge, you bear the construction cost. If you cut corners while building the bridge, guess what? It's your maintenance cost and you're paying for it. So this logic is sort of an interesting logic. Those of you from the state realize that this thing doesn't work out for all projects. So those of you who know I-69 know what's going on there. But in this particular case, this was a very big win. But one of the things that was interesting was that a lot of care was spent in anticipating and planning the contract. The terms of the contract, how you're going to measure who's responsible, who bears the risk, all of those things were interesting. So this was, for us, it was a wonderful project because it actually turned out that the person who signed off on it is the president of the university. The person who negotiated all the legal terms is the legal counsel for Purdue. So it turned out that we could count on people here to help us interpret all of the data. It actually was an interesting opportunity for our students to learn about this notion of these. Now, what's also interesting about this is that we use this as a vehicle to we use this project. Part of the project was to do a lay of the land study. What are experiences with these projects? And what's interesting about these public-private partnerships is that these are very common in Europe, but they are very uncommon in the United States, okay? And so it's an interesting question as to what about this should be adjusted so that one can get the infrastructure spend to be modest while getting the outcome. So this is sort of an interesting project that we managed to do. A second project which is of interest to the state is the future of the introduction of commercial autonomous vehicles. Okay. Now, if you think, why does the state care? Well, all state departments of transportation are sort of anticipating that this is going to come. They don't know the speed at which it'll show up. They don't know how many sensors they should embed in roads and use camera information, et cetera. But they do know that if you facilitate their success, first, if you don't facilitate their success, things can be very bad for the state. And of course, the tagline in all of our license plates is Crossroads of America. There's a lot of traffic that goes through the state. So if in fact the nature of that traffic changes, then we have to anticipate and be ready for it. So one of the questions that they were interested in is to say, how do we maximize the economic impact of the introduction of commercial autonomous vehicles? So that was the question. And so this is, and part of what they were saying is, how can we set up the system so that we can anticipate the benefits? So if you think about benefits, one way that we've been looking at it is to look at what are called primary benefits and secondary benefits, and I'll describe them in a minute. And one of the things we wanted to do was to sort of think about a set of options that can maximize the economic impact. And so again, since this is funded by the state, they're looking at the economic impact in the state. So we don't care if Ohio makes money and Kentucky makes money. We want to know what happens to Indiana. And sort of the role of data provision. And one of the things that's sort of very interesting is that infrastructure providing companies. So if you think about the state of Indiana, they have 300 cameras across various highways that are continuously recording information. And the question for them is sort of what is the monetary value of this data? Because historically they've been building roads and then they charge toll, et cetera. But there's actually, the data is a gold mine, because guess what? Google is collecting data and managing the data and getting you to use it. Every parcel distribution company needs access to where the congestion, et cetera, is. So these are some of the things that we've been looking at. So what are some basic questions? So if you think about business opportunities, I'm going to try to divide them into two categories, what I call primary effects and secondary effects. So the primary effect is really a question which says, how does the introduction of autonomous vehicles for transporting my products help my business competitiveness? Very much like you need something moved. It used to be picked up by a trucking company. Now there's a self-guided vehicle that pulls up, you stick things on it, off it goes. Now you might say, well, what's the benefit to me? Well, so that's one piece. The second benefit is, if in fact this became a reality and you're a provider to this industry, how might you utilize that capability? So I'm going to sort of think about these two pieces separately. So and by now you would have noticed that if you ask me to make a presentation, one of the things I'm going to draw is a supply chain, right? So think of it as shippers. So these are people who want things to move. Of course, they need a vehicle to move it, and they need a road infrastructure. So if you think about the primary business impact, it's all of these players. So all of these players are involved. The shipper has a primary business impact, but the shipper uses vehicles, uses road infrastructure. Now imagine that you added sensors, you added software, and you added maintenance, and you added manufacturing. Well, now you have a secondary business impact. And that is that in order to keep this infrastructure going, you need very accurate sensor information. You need software that's processing it, giving you information. Any maintenance that's required, you need that happen. So you can think about the fact that while a shipper would get a value, there may be other players that would play a role. And you might think about the fact that if you are Indiana's Department of Transportation, while you enable all this infrastructure, you want to make the business case that bringing in autonomous vehicles is not a net negative. So you might think, well, who's worried about it? Well, there are 3 million truck drivers. They're all worried that trucks are going to drive themselves. Okay? So if you want to know what's happening in the state of Indiana, last year there was a bill regarding commercial autonomous vehicles, and the bill was tabled because they said we don't know how to make a decision. So part of this is to try to get us to think about this decision. So again, what are things you could think about? 2 days ago there was a conference, there was a meeting in Indianapolis, and so I went around asking people, well, what are the primary, secondary benefits? What do you think will happen? Well, there are many things that you can anticipate will happen if you have autonomous vehicles. First, I know that Shelley in our first talked about electronic data logs and the fact that if you're a driver, then after you work 10 hours, you've got to shut down, and the data log automatically shuts down your truck if you're at the wheel, right? Well, if there's no human, that doesn't apply, right? Because the software can run 24 hours. So the truck can be operating 24 hours. Well, of course, the batteries have to get charged. You've got to fill fuel. The second is quick response deliveries. You decided at 2 a.m. that you want to order this from Amazon. Well, there's an autonomous truck that delivers it at 5 in the morning. Okay? More flexible delivery schedules. Predictable deliveries. So now, because you're driven by software, you can be rerouted by software. You can take all these exits. So right now, any of these things, if you run your Google, it gives you a prompt. You choose. There it will be optimized. And really, IoT is the Internet of Things. You can use that to synchronize deliveries. Earlier, we had a conversation. Aaron was talking about using blockchain. So within blockchain, he mentioned smart contracts. You can have similar kind of back and forth between the sensors and the devices to get things to happen. And so you might say, what's the business value of all of this? And in bold, I have the business value. That is that if you have better on-time, reliable deliveries, then that means that all the just-in-case stocks that you have disappear, and there's lower cost of operation. If you have faster deliveries, and you can deliver faster, you might be able to command a premium price. And so basically, if you have a lower response time because you can leverage the logistics system, then that basically means a more agile business. And so even though we don't see this when we first think about autonomous vehicles, these are all the ripple effects that one can anticipate in the system. In fact, 2 days ago, one of the things that the Indiana Department of Transportation started anticipating is, well, how should we plan the future of our road network if we're going to be particularly interested in minimizing last mile delivery? That is, where are our industries expecting deliveries? What technology of the truck should be there, and how should the infrastructure in the future be anticipated? Where do we have exits, et cetera, so we facilitate. So this is a very big deal, and I think they've been planning ahead of it. The bottom line with this is for the state to say, if we can do all these things and make the businesses more competitive, then that's the way we'll create economic value. Now, if you ask me, one of the things that, look, we're sitting in a university with a lot of engineering. So we sort of believe in the power of competitiveness and always getting a better mousetrap. But when you think about this better mousetrap, one of the things that I think analysis like this helps you to anticipate is how do you explain to the public what you're going to do with the people who might be impacted. And notice the reason these two are in there is if, in fact, you're going to provide products with premium capabilities and premium functionality, you're going to need people who are going to do those stages. So all that is happening, and this is one simple way to think about it, is rather than driving the truck, you might be delivering logistics value in unloading things, helping with retail, et cetera. So you can actually preserve or increase the value generated. Here, for example, is the secondary business impact. And this is something that's actually, even though it acts like a secondary business impact, it's something that can actually be the tail that wags the dog. And that is that there is the claim. So right now, if you look at the width of the lane, none of you may have actually measured the width of a lane, but the data is that it's 12 to 14 feet. And in fact, the federal government is trying to make it 15 feet. Right? Now, the problem with it being 15 feet is that since you've got to acquire the land and do all of these things, what we end up with fewer lanes that you need. Okay? So there's always the question, hey, can I get an extra lane? Okay? Well, it actually turns out that if you have precision autonomous vehicles, the theory is that they only need 8 to 10 feet because they can be driven so precisely you don't need the extra buffer. So if you collect 6 feet from one side and 6 feet from the other side, because you have one dedicated lane, all of a sudden you have an extra passenger lane. Okay? So what's interesting about this is you created this new lane out of thin air because you have dedicated lanes for commercial vehicles that are using less width. So this is really potentially a big game changer. Rather than the billions of dollars it will take to create infrastructure, you sort of use software and the special guiding to free up space so that passengers get an extra lane that you can flip around. Now, if this can happen, this can be a very big deal, right? And so now, of course, what I didn't realize, by the way, and this is what happens when you talk to a civil engineer. So I was saying, well, isn't this great? And he said, yeah. But remember, if you're going to build that, you have to worry about the pavement. And if you tell me that you're going to drive next to the pavement, I need to add more. I said, OK, add that to the pavement. He said, OK, and if you tell me that you're going to use this particular lane, I need to reinforce the asphalt. OK, reinforce the asphalt. OK, those are a few other things I haven't accounted for. But what will end up happening is this could very well free up a lot of capacity and decrease congestion. There was an estimate that I think drivers in Chicago waste 138 hours a year on traffic congestion. Okay, this came out a few days ago, right? So some of these things could be a very big deal. So, of course, then there's maintenance of vehicles, platooning, and lots of other things. And, of course, there are guesses regarding the future of energy. Now, why are we involved in a project like this? We think that this is a wonderful way for us and our students to be engaged in thinking about the future. What's going to happen to the future of transportation? How is it going to affect industry? How will it create value? So here are some examples of things that we've been discussing, and that is that we've been thinking about, hey, if we're planning for autonomous vehicles, how might some coordination enable congestion reduction? How might we use logistics leadership to attract new business? And one of the phases of this study is that we're actually doing a very short survey with 10 questions. So this is a little plug to say, hey, if you have an industry, if you're a business in the state, and you don't mind answering 10 questions, then we'll send you a survey, and that'll be of great help to us. Part of our goal is to sort of see how is industry thinking about the competitiveness that can be unleashed by such new initiatives. I'm now going to switch gears and talk about the Wabash Heartland Innovation Network. A few words related to it. We discussed it in greater detail in the fall conference. But this is an initiative funded by the Lilly Foundation. And it's centered around 10 counties around Tippecanoe County. As I mentioned, Johnny Park is the CEO of the WIN network. And part of the goal that we're involved in is two specific goals, and I'm just going to give you a small introduction to each piece. One is focused on, and the main goal here is to build a manufacturing ecosystem. There's a similar effort to create a digital agriculture ecosystem. And these ecosystems, the hypothesis is that effective deployment of IoT, or the Internet of Things devices, can enable competitiveness. So that's the belief. Now, we're involved in two pieces. One is related to what's called WIN manufacturing education. And this is to look at all the companies in this region. And I think today the updated number is 302. So there are 302 manufacturing companies in this 10-county region. And part of our goal is to find a way, working with Roy Vasher, who had asked a few questions this morning, and Angus McLeod, Steve Dunlop, and several of our students. One of the things we've been focusing on is how do we create education pathways so that people can understand, that is, companies can understand, how they can get value out of adoption of IoT tools. Okay, that's what. So what we've done at this point is visited or directly talked to about 100 different companies to get an idea of how they think about competing, what they know about value stream mapping, et cetera. And so step here is to basically our focus on creating manufacturing pathways. Maria just told me I have 5 minutes, so I'm going to give you a 5-minute version of some other things. One of the other things that we've been doing is the focus is to, if you really are creating an ecosystem, we need to find a way for companies to become visible. So when you walked in, you would have seen Jack at the entrance there. There's Jack. So what we have is a tool that Jack has been demoing, and this is to get visibility into the capability of companies in this region. And what we mean by capabilities, it's a lot of detail, and I'll show you. So here, for example, we've created a Google map. If you click on any of the companies, this, by the way, is the 10-county region. That's our focus. If you click, all these companies are companies that we had data here. So if you go into any one company you can see, who has lathes, who has lasers, who has hydraulic presses, what kinds of products do they make, what is the name of the company, what certifications they have. We're just getting started. So a lot of this data has been accumulated by web scraping and some natural language processing. And part of our goal is to get to a few things. One is, in each of these counties, there's a local economic development official whose job it is to attract business. So we're trying to give them enough information so they can fine-tune the business case for a company who wants to come here. The second is that if you think about companies, then companies have procurement managers, and we want to help them find companies in this region. And the reason they may not find it is they say, well, I'm looking for a titanium bolt. I searched titanium bolt. I didn't find anybody. But then you might say, hey, but there's somebody who does titanium machining, and if you give them a blank, they can machine it for you. So we're trying to make it whereby the focus is on capability rather than current products. And finally, sometimes there may not be one company that can do it, but a collection of companies that can do it. And that's why we're trying to create prototype supply chains. Now, there's a little pet project that I think is going to be a big deal. I'm trying to convince Steve that's going to be. And that is that sometimes what happens is a company may need a part. And in fact, I was talking to Reggie about this before lunch. A company may need a part, and they say, hey, I just need this part. Tell me what it's going to cost you. I need it tomorrow. Well, you need a mechanism for it to be visible, and to make that part may require 3 different companies, but you don't want to spend an inordinate amount of time. So we're building a tool which is called a capacity market, and this capacity market can allow transactions for small volumes, high margins, and this could get a company through the door. Now, there's some interesting optimization back end associated with it. So I think that pretty soon we'll have all these tools available. What Jack was demonstrating is one of the first of these tools. I want to get you to sort of, I'm pretty excited about this project we have with Oak Ridge National Labs, and this is from the Department of Energy. And a lot of this is, look, I'm a faculty member, so if there's something I can learn, count me in. I'm in the car driving to Oak Ridge, 7 hours away. One of the things that's interesting is that if you look at electric vehicles, you always hear about lithium-ion batteries and cobalt, et cetera. What you don't hear about is graphite, okay? So, well, what's the big deal with graphite? The amount of graphite used in the anode, every battery has a cathode and an anode. So in the anode, most batteries use graphite in the anode. And you need 99.99% pure graphite. And the volume of that graphite is 10 times the volume of lithium. What's the problem? There's synthetic graphite and natural graphite. There's a lot of price variation. And the question at Oak Ridge National Labs is they have a new technology. And their question is, what is the return on investment with our investment in this technology? So that's the question we're trying to answer. So I think, Maria, I'm down to 1 minute or 0. Okay. So there's a bunch of interesting stuff related to graphite. The one thing to note is the reason it links to everything else is the shape of the growth curve for electric vehicles. We're at 500,000, a volume of about 500,000 now in 2018. The projected volume, normal case, is 20 million electric vehicles by 2030. An aggressive case is 30 to 50 million electric vehicles. And if we ban all internal combustion engines, it's 93 million, okay? So this is the big deal. For this big deal, you need a lot of graphite. So some of the things, so I'm going to skip all of these things and get you to the fact that there are a lot of things that are happening in the world right now. Everybody's sort of figuring out new mining for graphite, new synthetic graphite tools. The federal government is trying to invest in technology. So if you're really thinking about an industry to think about, think graphite. Remember? We talked about plastics, then we talked about analytics. Today, the word is also graphite. Okay. So anyway, what we did is, of course, first we can write some interesting equations. We're professors, we like to do that. The one number that we generated is an estimated net present value of profit in billions associated with different changes in technology. And this is a useful number because Congress asks the national labs to say, we're funding basic research, but what's the return on investment? How can it transform an industry? So a quick summary. I'm going to skip this thing. So just read the things in red. We're doing exciting applied projects. We're eager to work on projects. Our goal is educational opportunities, but we professors like research too. One of the great things about Purdue is we can contract efficiently. We deliver on time with excellent results. And to get started, call Steve Dunlop. Okay? Thank you.